Okay, you guys, we are almost done this last week. Hopefully you're doing what you need to do to finish strong. Today's date 1/11/21. So we're going to have a test on Thursday on trigonometry. So before we go ahead, let's go ahead and write what we know. Okay, sine, you're going to need these. Sine of theta is equal to the opposite over the hypotenuse. You're going to need that written down somewhere. Cosine of an angle is equal to its adjacent side over the hypotenuse. And finally, the tangent of an angle is equal to its opposite side over the adjacent. Okay, I'm just gonna highlight these because this is everything. This is what we need to know. Okay, and there's going to be some special right triangles too, and I'll write those down when we get to those. Okay, so right off the bat, first thing, boom. First thing we need to know is this: find the trig ratios for both acute angles. Okay, so acute angle, that's either angle A or angle B. Those are both my acute angles. So it doesn't really matter where we start. I think I'll start with angle A because alphabetical order. And if I start with A, then I can name my sides. My sides have names like opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So if I do that, then from angle A, the 8 is directly opposite of it. The 6 is next to it or adjacent, and the 10 is opposite of 90, therefore it is the hypotenuse. Now all we want is a fraction, okay? So let's talk about the ratios. So we're going to do this. This is all we need. We're going to do the sine of A. So this is on the test. Sine of A is equal to its opposite over the hypotenuse. 8 over 10. Answer. Done. Easy. Cosine of angle A. Cosine of angle A. Cosine is equal to the adjacent over the hypotenuse. 6 over 10. That's it. Boom. Done. Okay. And then tangent of A. Tangent of A is got to equal, let's see, the opposite over the adjacent. So it's going to be that 8 over 6. Okay. Boom. Now, what about angle B? So because we want both, this is for both. So if I go around the triangle, come to angle B, then this is no longer my adjacent side, but that's my opposite side. So it changes, doesn't it? It changes. So I'm going to change this up. Okay, angle B, 6 is my opposite side, and my 8 is my adjacent. The hypotenuse doesn't change because it's always opposite of 90. Okay, so there you go. So, sine of B. So, sine of B is the opposite over the hypotenuse. 6 over 10. The cosine of B is equal to its adjacent over the hypotenuse. 8 over 10. And the tangent of B is the opposite over the adjacent, or 6 over 8. I think if you look at these two things, you'll see something similar. Anyway, that's what we'll talk about in another class. Now, okay, good. You got that? That should be easy. You should be able to do that on the test on Thursday. Okay, number 2. Solve this triangle by finding the missing sides and angles. Okay, so let's go ahead and just go right there. Okay, so 54 degrees. That's my angle. So I'm going to find T. Okay, so if I want to find T, I'm going to go ahead and go with my opposite over my hypotenuse, right? Opposite hypotenuse for my angle. Opposite is my hypotenuse, okay? Opposite hypotenuse, let's use sine. So we'll go sine of theta, or sine, not theta, but 54, because that's my angle. Is equal to the opposite over the hypotenuse, so it's going to be the 10 over the t. Now we've learned that if the t is on the bottom, or the variable's on the bottom, we'll multiply by the t, and then we'll divide by the sine. So we'll just replace, we'll just multiply up by the t, divide by the sine of 54. So t is equal to, comes up here, sine 54 goes there, and we just need to use our calculator. Okay, so what is 10 divided by, what is 10 divided by sine of 54? We can answer about 12.36. Easy. Angle C, well that's easy because these two angles have to add up to 90. So to find angle C, we're just going to go 90 minus 54 degrees will give me angle C. All right, it's 90 minus 54. I should be able to do that in my head. 36, yeah. So angle C is 36 degrees. And then finally, to find this side right here, we're going to use, I'm just going to use Pythagoras theorem. It's just easier, okay? Or you could use trig. I don't know. Maybe I'll use trig. Why not? 36. I'll use trig. I guess you could use Pythagoras theorem, but I'll just go opposite over adjacent, which is tangent. I might use tangent of 36 equals its opposite, which is my little c, over 10, which is my adjacent, right? Tangent. And I'll multiply up the 10. You could use Pythagoras theorem. This squared plus this squared equals this squared, but I think trig's faster. Okay, and then we got 10 tangent 36, and I get an answer of about 7.26. Okay, there we go. Boom. For 3, solve this triangle by finding the missing angles and sides. Well, all right, I have, let's see, how about I find this angle right here. So if I find P, then the 5 is my opposite side. My 13 is my hypotenuse, right? Opposite hypotenuse, it's got to be sine. So let's go sine of angle P is equal to my opposite divided by hypotenuse. So my 5 over my 13. Now, if we need the angle, this is what I saw in your homework. You guys aren't getting it. If you need the angle, you have to push the inverse button. You must sine inverse, okay, of 5 divided by 13. Okay, you have to. You have to. Okay, enter. I get about a 22.6 degree angle. Okay. Angle I, that's easy. Angle I is easy because we're going to subtract from 180 degrees. So, I'm sorry, not 180, but 90. These two add up to 90. So I'm going to go 90 minus 22.6 degrees. Let's see, 90 minus 22.6. I get an answer of about 67.4. So angle I is 67.4. Angle I, 67.4 degrees. And then finally, may as well use Pythagoras theorem to find this missing side. I squared plus 5 squared equals 13 squared, right? I squared is equal to, subtract 13 squared minus 5 squared, right? Let's see here. 13 squared minus 5 squared. 144. Square root. I is 12 this side. Okay, alright. Moving on. Okay, find the exact values. Now the exact values, we need also to have our special right triangles, right? Our special, call them special right triangles, because it'd be really helpful. So I knew that this is a half of a square. If we have a 45, 45, 90 triangle, then these two sides are equal, right? So that's easy. X is 12, right? 45, 45, X is 12. Boom, that was easy. Now, we could use Pythagoras theorem. We could go 12 squared plus 12 squared equals c squared, but a faster way is whatever this side is, the diagonal or the hypotenuse, always x times the square root of 2. So in this case, y is just going to equal 12 square root of 2, okay? We did this a couple of weeks ago. Number 4 is a 30, 60, 90 triangle. That's a special right triangle too. It turns out in this 30, 60, I hope you guys have these written down. 30, 60, 90. Turns out that this side is always twice as big as this side. Okay? X, 2x. This side's always twice as big, so this side's got to be 10. Boom. That's just 10, right? That's it. Easy. Okay? And if that's the case, then the longer leg is always whatever this is times the square root of 3. So the y, if this is 10, this is going to be 10 square root of 3. Okay? There you go. Much faster than the Pythagoras theorem or even doing right triangle trick. Okay? Now this is the same triangle, but it's laying on its back. So it's really kind of laying on its back. got knocked down, x squared to 3, x and 2x. So the bummer is that the 12 is sitting right where the x squared to 3 is. So if we want to find x, we take our 12 and set it equal to our x squared to 3. Okay, because this has got to be some square root of 3. It's not. So if I solve for x, which is what I want to find, divide by the square root of 3, divide by the square root of 3. 12 divided by square root of 3 is just simply going to be the square root of 4. 4 square root of 3, my bad. 4 square root of 3 is what x is, okay? So if this is 4 square root of 3, this one's twice as big, so it's going to be 8 square root of 3, okay? Almost done. Okay? A wheelchair ramp is constructed so the height of the ramp is 9 inches and the ramp is 4 feet. So let's change that to inches. Inches, let's make that 48 inches. Don't make that mistake. Okay, so let's draw a ramp. Here's my ramp. And theta, right? My ramp's 48. That's the ramp because that's inside the ground. This is 9, right? And if I want to find the angle, well, that's my opposite side. That's my hypotenuse. Opposite hypotenuse, and that's going to be my sine. Opposite hypotenuse is sine. So we'll take sine of theta is equal to 9 over 48, opposite hypotenuse. But if I need to find the angle, I must use these buttons. So I'm going to use sine inverse, right? So I'm going to go sine inverse. I have to. It has to be the inverse button of my 9 divided by my 48. Okay? Boom. About a 10.8. That's pretty big because I think code is 4.8. I think that's way too big. Poor Grandma's not going to be able to get up that. Okay, last but not least, this one. Find the area. So the area of a triangle is 1/2 base times height. And we don't know either one. But if I cut it straight down the middle, and if I look at just this triangle right here, okay? So if I find the area of that one triangle, I'll just double it, okay? So let's just look at the orange triangle. That's my thought. Let's just look at the orange triangle, okay? Let's just look at the orange triangle. So if I can find the area of the orange triangle, then I'll just double it, okay? Since it's a nice isosceles, that is 90, okay? And what I need to do is, that's going to be half of 135 is 65 degrees, which makes this 25 degrees, right? Okay, because I add up to 90. Now, I need to know the base and the height. Well, let's find the height first, okay? Let's find the height first. Okay, opposite hypotenuse. Opposite hypotenuse, right? Opposite hypotenuse, opposite hypotenuse, opposite hypotenuse. Got to be sine. So let's go. My height, I want to find the sine of theta, but theta is 25 degrees. It's equal to my opposite, which is h over my hypotenuse, which is 12, okay? There it is, okay? Right there. Sine of theta, but theta is my angle, 25, opposite, which is h, over hypotenuse, which is 12, okay? Multiply up by the 12, okay? I'm going to multiply the 12 up, right there, multiply the 12 up, and I'll take my 12 times my sine of 25 equals h, and let's just use my calculator, okay? Calculator, and I've got a 12 times the sine of 25 degrees, and I get an answer of about 5.07. Okay, so the height of this triangle is about 5.07. Now I need to find the base. Let's call that b. I could use Pythagoras theorem, but I may as well just, for me, I'm going to use cosine, because I think it's faster. So I'm going to set up, because I'm going to go adjacent over hypotenuse, so I'm going to go cosine of 25 is equal to the adjacent side, which is b, over the hypotenuse, which is 12, okay? Again, I'll multiply up the 12, 12 up there. I'll have 12 times the cosine, sloppy cosine of 25 is going to give me b. This is that base right there, okay? Calculator time, 12 cosine 25, I get an answer of 10.87, let's round up 10.9. Okay, so that's that base, 10.9, right? 10.9. Okay, so then to find the area of this triangle, let's go area is equal to 1/2 the base, 10.9, times the height, which is 5.07. And then we're just going to double that because we got both triangles. Let me get this first. Okay, so this is my first triangle. I'm going to go 0.5 times 10.9 times 5.07. And I get an answer of about 27.63, but I'm going to double that because I've got two triangles. So this triangle was 27.6, but I times that by 2 because there's two triangles, and I got an answer of 55.26. Okay, all right, centimeters squared. That's it. We'll have a test on Thursday. Hopefully you guys will do all right. Okay.